Let's read the question. Find the length of the chord intercepted by the circle x square plus y square minus x plus 3y minus 22 equal to 0 on the line y equal to x minus 3. So let's make the figure for better understanding of the question. So there is a line. So on this particular line the circle is passing. Okay, suppose this is a circle and this is a line. Okay, on this line the circle is passing. So now they are asking us to find out this chord length. So this is the chord, right, where the circle is touching. Only that internal part, the inside part of the circle is called as a chord. So we should find out this length of this particular chord. That is what the question has given, and they gave the equation of this particular line, that is y equal to x minus 3, and also they gave the equation of the circle also. So that is x square plus y square minus x plus 3y minus 22 equal to 0. So this is the equation of the particular circle. So now by using this information we have to find out the length of the chord. Alright, so let's say the center we will just take it as C. Alright, so now we have to find out the center of the circle by using the given equation of the circle, and also we can find the radius also by using the given equation of the circle. So first we'll write the given circle equation. So I can write here given circle equation. So what was the equation? So I will just take this as S. So I can write S equal to x square plus y square minus x plus 3y minus 22 equal to 0. So we are just representing this particular circle as S. Alright. So now we'll find out the center by using this particular one. So for that I'll just compare this given equation with the general equation of the circle. So what was the general equation? Ax square plus by square plus 2gx plus 2fy plus c equal to 0. So now by comparing the general equation with the given equation we can find out the center of the circle. So what is the center? Center is nothing but minus g comma minus f. So let's compare. So we'll be getting the center as 1 by 2 and minus 3 by 2. So we got the center. Let's find out radius also. So I can write here radius, which is r equal to under root of g square plus f square minus c. So let's submit these values. So the g value will just submit here, that is 1 by 2 whole square plus the f value is minus 3 by 2 whole square minus the c value we could see, that is minus 22 is the c value. So I can write this as minus 22 under root. So let's try to solve this forward and we'll see what do we get. So 1 by 2 whole square, in the sense that we'll be getting 1 by 4 plus minus 3 whole square, that is 9 by 4 minus of minus plus, so plus 22 under root. As the denominator is same for both of these, so we could just do the LCM for this. So I can write this as 1 plus 9 plus 22 into 4 whole by 4 under root. Alright, so this I can write as 9 plus 1, which is 10, plus we will just multiply this. 22 into 4 is nothing but, that was 88 by 4, there is under root. So this I can write 88 plus 10, which is 98 by 4. We can just cancel this. This is 2 2's 4 and this is 2 49's 98. Alright, so we're getting this as under root 49 by 2. So we'll just separate them, root 49 separate and root 2 separately. Root 49 is nothing but, it was 7. Alright, so 7 square is nothing but 49. Then the root and square get cancelled, so we are just remained with 7. So finally the radius we got it as 7 by root 2, whereas the center we got as 1 by 2 minus 3 by 2. So by using these particular things, this particular information, we could even find out the distance. Alright, so for that, by using this particular information we can find out the perpendicular distance. See here in the figure, if you just observe, from the center of the circle we can find out the perpendicular distance. This distance from center, this perpendicular distance we can find out. Alright, so to find out the perpendicular distance from the center of the circle, we have the formula that I'll write here. Therefore perpendicular distance from center. Alright, we'll just write the center as x1 y1, so that is to the line equation was already there with us, so that is ax plus by plus c equal to 0. So that gives us ax1 plus by1 plus c whole by under root of a square plus b square, and we'll be writing this in the mod. Alright, so let's try to do this and we'll see what do we get the value as. Alright, so now a value which we already had above, we will just submit that, and the x value also will just submit, and we'll be finding out the values over here. So now the given equation of the line I'll write here, then we will just compare. So the line equation is y equal to x minus 3. If I bring this y to other side, so I'll be getting x minus y minus 3 equal to 0. So now if I compare with the general equation of linearity, then I'll be getting a equal to 1, b equal to minus 1, c equal to minus 3. So this is the general equation of a line, straight line. Alright, so we had a straight line, right? They have given the straight line equation, this equation. So I have taken that and I have got the a, b, c values over here, and even the center will be using, by using the center, I'll write the center values also here. C is how much? 1 by 2 and minus 3 by 2. So we'll use all these values and we'll just submit here and we'll see what do we get. Alright, so now a value is how much? That is 1, and the x value is 1 by 2, whereas the b value is minus 1, and y is minus 3 by 2, whereas the c value is minus 3 whole by, so now I can write under root of a is 1 square plus b is minus 1 square. So let's try to solve this forward and we'll see what do we get the answer as. So I can write this as 1 into 1 by 2, which is just 1 by 2. So this is minus into minus plus, so I can write this as plus 3 by 2. This is minus 3 whole by, this is 1 plus 1 under root. Alright, so let's solve this forward and we'll see what do we get this as. So this is 1 plus 3 minus 3 into 2, the LCM I'm doing here, by this is root 2. I hope this is clear. 2 into 3, so that is what I have written as the LCM. So this is 3 plus 1, which is 4. 4 minus 3 2, it was 6. So this is 6. Of course there is mod, right? We forgot to make the mod, so we'll write mod for all of this. So this is 4 minus 6 whole by 2 by under root, when there is mod. So 4 minus 6 is nothing but it was 2 minus 2 by 2 whole by root. So 2 ones get cancelled, so we are just remained with what? Minus 1 by mod, minus 1 mod by root 2. So as there is mod, we could just write the value as 1 by root 2. So this is a perpendicular distance. I'll just show the figure again for your clarity. So this is a perpendicular distance from center to the given line. This perpendicular distance we got. So what was the distance we got? That is 1 by root 2. So now we even got the perpendicular distance. Now we can find out the length of the chord. So I can write here length of chord. So we have the formula to find out length of the chord, that is 2 into under root of r square minus d square. So let's submit the value 2 into the radius, the r value that we already found, that is 7 by root 2. So let's submit that. So I can write 7 by root 2 whole square minus the d value just now we got, that is 1 by root 2, that also I'll write here 1 by root 2 whole square, and there is under root. So let's try to solve this forward and we'll see what do we get the value as. So 2 into this is 7 square is 49, and root 2 and square get cancelled, only 2 is remained, minus this is 1 by root 2 and square get cancelled, so here only 2 is remained, and there is even under root. So this will just solve this forward. So this is 49 minus 1 by 2, and there is under root. So this will write as 2 under root of 48 by 2. So we could just cancel here. 2 we can do with 2 table, that is 2 1s, and this is 2 2s 4, 2 4s 8. So we are getting this as 2 under root 24. Alright, so now we'll just try to solve this forward. So this 24 we can actually write this in the 4 multiples. So I can write 2 under root of 4 6 4 6 it was 24. So I will write root 4 into root 6. Okay, this 4 and 6 I wrote separately. So root 4 is nothing but it was 2. So I can write this as 2 into 2 under root 6. So 2 2's it was 4. So I will be getting this as 4 root 6. So finally the length of the chord we got 4 root 6 units. I'll just quickly revise the complete thing which we did, then we'll get 100% clarity. Alright, in the question they asked us to find out the chord where the length of the chord where the circle is passing through this line. Okay, they gave the line equation and they gave the equation of the circle. By using the equation of circle we got the center and we got the radius of the circle. So by using this particular information which is the center of the circle, and we have used even the given equation of line, and then we got the perpendicular distance of the circle. This perpendicular distance we got. So when we know the perpendicular distance and also when we know the radius of the circle, then we can easily find out the length of the particular chord which is intercepted in the circle. If this is a circle, if this is the chord, and if you know the perpendicular distance from center of the circle to this line, that perpendicular distance, and if you know even the radius of the circle, then we can find out the length of the chord. So that is the way we solved, and we got the length of the chord as 4 into under root 6. So this is all about this particular question.